Now, suppose that there is a pole. Okay, we use our pole as our reference point. At the pole, the displacement is 0. Now, a car starts from here and moves in this direction. T 0 second, 5 second, 10 second. If I observe the change in the position of the car, at first it started at the pole. So at first the displacement is 0 meter. After 5 seconds, now it has come here. We measured the position, which is to the right side of the pole. So it's a plus, let's say it's 10 meter, okay? 10 seconds later, now its position is here. So it's changing the position. New position here is plus 20. Remember, position has a direction. So you have plus or minus. If it's on the left side, then you get a minus. Now, this motion of the object, I can put it in a graph, right? So what graph? Position time graph. Here, S unit, M, T in second. All right, 0 second, 5 second, 10 second. How does the position change? 0, 10, 20. We do it like this. 1, 2, 3. Okay, we get a straight line like that. This straight line showing what is the current position at this particular time. For example, if I want to find out what is the position of the object at 7.5 seconds, then I would take in the middle 7.5, whatever here, then I get the position. It's a positive, right? So is it at 7.5 seconds, this instant, it is at the right side, this far away from the pole. So always we have a reference. What is our reference here? The pole is our reference. And usually the reference point, we use the starting position as the reference point. Okay, the starting position as the reference point. Okay, now from here, I can get the position, right? I can get first information is I get the position. The second information I can get from the graph is the behavior of the motion. What does it mean by the behavior of the motion? It means like whether it is increasing velocity, decreasing velocity, or constant velocity. How do I find that? I can find the gradient of the line. Okay, so calculate velocity. Why the gradient of the line? Okay, if I take the gradient here I draw a triangle. This is the change in the y. This is the change in the x, right? What is the change in the y? The y-axis is the displacement. So it's a change in the displacement divided by the x-axis is time. So it's change in the time. So if I calculate the gradient, m y over x equals to change in displacement over change in time. What is this thing? What is this thing? If you take the unit, look at the unit, m divided by s, m over s, you get ms minus 1. This is a unit of what? You see, when from the gradient, look at the unit, you get the unit of velocity. So that means gradient equals to velocity. That's it, straightforward. Okay, gradient equals to velocity. So if you can calculate the gradient of the graph, you get the velocity of the object. Okay, now we get a straight line graph. What is the gradient of a straight line graph? It is a constant value, does not change. Okay, so the gradient does not change. That means the object is moving at constant velocity. Okay, so constant gradient, constant m, that means constant v. Okay, so you see from the displacement time graph, I get two information. First information is the position. Second information is the speed or the velocity. So I would say that my ST graph tells us what? Let me write it down here. Tells us position with respect to reference point, starting position, And the gradient of the graph tells us the velocity, or I call it the behavior of the motion. Okay, so ST graph tells us position with respect to the reference point. So we is always in relation to the reference point. Okay, now what if I give you a graph like this? And this is same ST graph, but the line is on the x-axis like this. What does it mean? The displacement is 0 over time, right? 1 second, 2 seconds, 3 seconds, 4 seconds later, it is still displacement 0. That means it has not moved. It is still at the original position, the starting position. So this one, object at starting point, object at starting point, and it remained at rest, right? Okay, so this is what the graph tells you. What about this graph here? ST. Okay, horizontal line at +5. What does it mean? Over time, is the object moving? You see, make it very clear. The position over time, 1 second, 2 seconds, 3 seconds, the position remain +5. That means at time 0, where is the object at time 0? The object is 5 meters to the right side. Initially, right? Here, +5 meters at time 0. That means it started there, not at the pole. It started at 5 meters to the right of the pole. And over time, 1 second, 2 seconds, 3 seconds, 4 seconds later, it remained there. Okay, so is it object moving? No, it's still at rest. Okay, the third one, this one. What do I mean if I say ST graph and the line is down here? This is minus, okay, -5. What does it mean displacement -5? At time 0, it started where? Time 0, it started at -5. So this is the pole. This is the pole. The object started here. Here, this is -5 meters to the left side. Okay, over time, is it moving? 1 second, 2 seconds, 3 seconds, doesn't move. This is also at rest. 3 graphs shows that it is at rest, but the position is different. Okay, so that is the horizontal line. A straight line shows that it is moving. Now, let's consider a different scenario. Let me change the diagram here. Let's say this one I erase. 0 second, 5 second, 10 second, and 15. The displacement 0 meter, 10, 30, and 60. Okay. You can see every 5 seconds, right? The displacement increased by not the same amount. Here +10, here +20, and then here +30. So if I were to plot a graph, just do a rough sketch. ST, 0 second here, 5, 10, 15. Okay, 10, 20, 30, 60. Over here, 5 seconds, 10. 10 seconds, it has come here. 30 and 6. 15 seconds, it is at 60. If I join this, I get a curved graph. You see here, over here, 5 seconds. Between here, 5 seconds. Look at the first 5 seconds. how much is the change in the displacement? In this 5 seconds, the change in the displacement is from here to here. How much is this change? This change is plus 20. In the second 5 seconds, what is the change from here to here? This one to this one. The change is from 30 go to 60. This is a plus 30 meter. In the same duration, the car travel longer distances. The first 5 seconds, 20, the next 5 seconds, 30. And it keeps on increasing. What does it mean? In the same duration, the car travel more distance. Speed equals distance over time. In the same duration, same t, the distance go on increasing. That means it is speeding up. The speed increases. Okay, speed increases. And you know, speed is what? Gradient. So the gradient increases. If you look at the graph, the speed of the object at every single point is going to be different. Okay, the speed is not same at any point on the graph. You take the point here, point A. What is the speed here? It's going to be different from point B, the speed here. Compared with the straight line, point A here, the speed here is the same as the speed here because it is on the same line. It is on the same slope. Okay, so gradient is the slope. So same slope, same gradient. But this one is different every time, every single second that the time passes, the speed changes. If I want to find the speed at a particular point, let's say I want to find the speed at point B. How do I find it? At this point on a curved graph, right? So to find the speed at point B, I would draw a tangent. What is a tangent? 什么是 tangent? 你看这边我画一个圆圈 ，OK， 我画在这边上面。Wait, okay, this one we have a circle here. If I draw a line across the circle, how many intersection points? 2 points, right? 1, 2. What is this line called? This line is called secant. A line that passes 2 points, secant. Now, if I move this line, if I move the line, I push it all over to the edge of the circle, such that it only touches the circle at 1 point. Then this line, we call it a tangent. Okay? A tangent line is a line that touches the curve at only 1 point. 1 point. Okay? A tangent line is a line that touches the curve at 1 point. So if I want to draw the tangent at point B, then I would draw a line that only touches point B like this. It is a straight line, guys. It is a straight line. So you have to draw a straight line that only touches point B, because you see at point B is actually, the line is actually curving. Okay, so you can actually draw a line that only touches that point. The point next to it, it starts to curve. It is not touching the line. Okay, of course you cannot get the perfect lah. You just do a approximation. So this one, after you draw the tangent, we would do the gradient of the tangent. Change in y, change in x. Okay, this is delta. Delta means change, the difference in the y, okay, divided by the difference in the x. We get the gradient of tangent at B. Okay, gradient of tangent at B. If I want to find the speed at point A, then I do the same for point A. But on the previous graph, we don't need to do that because every point, they have the same speed. So since gradient is speed, That means this is also speed, but we call it differently. We call it instantaneous. Instantaneous speed. That means the speed at this particular instant. What is the time for point B? Okay, maybe 13 seconds. The speed at this 13 second. The very next second, it changes. The very next second, 14, it changes. What is the speed at point A? Here, okay, 7 seconds. Find the instantaneous speed. We do the same. That is the speed, we find it. The very next second, it changes. Okay? So if question asks you to find instantaneous speed, then you know what to do. But this one, the previous graph, are we finding the instantaneous? No, we are finding the average because it's all the same. When we calculate the gradient of this line, we are getting the average speed or the average velocity. Okay, I call it speed or velocity is the same thing. Okay, it's just that the direction here. Okay, now 1 minute, we go to the next slide. Okay, for Fong and Nicole, just now we decided the tuition replacement to be on Saturday night, 7 p.m. So yeah, currently we fix it at that day lah, because so far everybody doesn't have any tuition on that night. But if you have tuition on that night, you let me know. Okay, Nicole said okay, all right, sure. Okay, now we go to the next one. Next slide. So we have looked at two graphs so far. One is straight one. Another one is the curve one. Let's compare these two. The first one shows over time, what happened to position? Position increase in the positive direction. That means it's going to the right side. What about this one? Same thing. Position increase. And it is also going to the right side, positive. All values are positive here. The difference between these two is that the gradient, this is the same. Over time, that means the velocity is the same over time. For this one, what happened to the gradient? Increasing or decreasing? Increasing. So how do you look at it? Without any calculation, how do you look at the gradient, whether it is increasing or decreasing? You see, 如果你要知道它的 gradient 是增加、减少、positive 或者 negative， 你直接放两个 point 在那个 curve， 你放一个 point 这边，你放一个 point 这边 ，OK， 然后你画它的 tangent， 我画一个 tangent 在这边 point A， 然后我画一个 tangent 在 point B， then 你 compare 哪一个比较 steep， 哪一个比较 steep, okay? Which one is steeper? Because gradient is slope, right? It's slope. The steeper it is, the higher the gradient. So the gradient at B is greater than the gradient at A. That means going from left to right, the gradient increases. Then you know the velocity increases. Okay, so here, gradient increases. So V also increases over time. Is it a positive gradient or a negative gradient? 你看它的 slope， 如果它是上去的，就是 positive， 往下来就是 negative。所以我们这个的 gradient 是 positive gradient。Okay, positive gradient that means 我的 velocity 是 positive velocity。Okay, positive velocity. So both graphs shows the object is moving to the right, but the behavior is different. First one moving at constant speed. The second one increasing speed. That means there is an acceleration. Okay, the second one shows there is a acceleration. Now, if I put another line here, this is car B. This is car A. Which car is moving at higher speed? Okay, very simple. You just look at the gradient. Gradient of B greater than gradient of A. So velocity of B must be greater than velocity of A. Okay, you just look at the slope. All right. The next one. What about like this? If my graph look like this, ST graph. Okay, two things we analyze always. We always analyze two things. First is the position itself. Over time, does the position increase or decrease? Increase. Positive. So position increase, and it's a positive value. Okay, it's going to the right. And the second thing we analyze is the gradient. Okay, put 2 points on the curve. Point A, point B. Draw a tangent. This one, the tangent is going to be like this one and like this. Which one is steeper? Tangent A is steeper. MA bigger than MB. So from left to right, gradient goes on decreasing. Okay, so gradient decreases and the velocity decreases. Comparison between these three graphs. Okay, so you can see the graph flattens. As you move from the right, it flattens. It's getting flatter and flatter. The slope or the steepness decreases. Okay, now, what about this one? Oops, wait, let me draw like this. Okay, 这个呢 ST graph. Over time, 0、1、2、3，它的 position 这样，它的 position 去 negative， OK， 减10、减20、减30。Over time, the position goes on to negative. That means it is moving. Moving where? If I sketch the diagram, this is our reference, our pole. So T, first second, 0. At the second second, here, position is -20. So 2 seconds, it is -20, so to the left side of the pole. And this keeps on increasing, okay, increasing. So it keeps going to it keeps getting further and further away from the pole to the left side. Here, you want to be careful with the value, because a lot of students, when they see the graph, they will think that this graph, this line means it is decreasing because it's sloping down. But is it decreasing? You look at the value, minus 10, minus 20, minus 30. Look at the numerical value. The numerical value is increasing. You're going from 10, 20 to 30 in the negative direction. Okay, because in mathematics, which one is larger in mathematics? Minus 10 larger or minus 30 larger? Minus 10 is larger, right, in mathematics, because minus 10 is closer to 0. But in physics, it's different. In physics, we say that minus 30 is larger. Okay, because the minus represent direction. We are actually only looking at the number 30. Okay, so it's like it is increasing in the negative. Okay, increasing in the negative. Okay, if I want to calculate the gradient, okay, I want to find out what is the velocity. Here, t equals to 30 seconds. Okay, then I calculate m equals to 30 divided by 30. 1. Our line is sloping downward, so we have to add a negative here. Because line that is sloping downward has a negative gradient. So negative 1 meter per second here. This is my V. So when you do the calculation, you will get a negative because the line is sloping down. And this negative means what? Means that it is moving to the left, which also line up with the position value. So the position value, you should get negative here, right? Negative 10, 20, negative 30. And also it is moving here. That's why your velocity is a negative 1 ms minus 1. Right? So these are the few types of graph. The common one that will be asked in the question. All right, 1 minute, and I will show you a few examples of the displacement time graph. Okay, now we look at one example here. Calculate the v velocity, okay, in the first second. Okay, so first 5 seconds, sorry, first 5 seconds. Okay, so you just do the gradient. V equals 10 divided by 5 equals to 2 meters per second. Okay, is it a positive or negative? Gradient is sloping up, so it's a positive. That means what? That means the object is moving to the right. Okay, so in the first 5 seconds, let's say this is the starting point O. What is it doing in the first 5 seconds? It is moving to the right at a velocity of 2 meters per second. So by 5 seconds, it would have reached here. Okay, point A. Point A. 5 seconds. Is it a constant velocity or a changing constant velocity? Okay, the graph is sloping up. Okay, now B. Calculate the velocity in the last 5 seconds. V equals here y10 divided by, again, 5. But this one is sloping down, so you have to put a negative, minus 2 ms 1. Okay, so it's a negative, that means it's moving backward. After coming here at point A in 5 seconds, between 5 and 16 seconds, in between here, you got 10 seconds. What is it doing here? 10 seconds, the position remain as 10. That means it is not moving. Okay, it is not moving here. The last 5 seconds, sloping down, your velocity is a minus. That means it moves backward. Minus 2 ms minus 1. Back to starting position. How long it rests at point A? Rest for 10 seconds. Then after 10 seconds at point B, okay, point B here after 10 seconds, it continues to go back and travel backward. If I look at the velocity, the negative will tell me that it is moving backward. If I look at the displacement, how do I know whether it is going backward or forward? You see the slope is like this here. This last part, if I draw it like this, the last part is sloping down, which means that the position is going from positive 10, positive 8, positive 5, okay, positive 2, and 0. It's all positive, right? It's all positive. That means it is all on the right side. So this is the person, it's all on the right side, positive. But it's going from 10, and then it has come to here, 9. Okay, then closer and closer and closer here, positive 2. Over time, it is moving to the left. By looking at the position, you know the motion, right? By looking at the change in the position, plus 10, plus 5, plus 5. I want to stress something is that this one, the S is showing position instead of showing distance. Not distance, okay? Not distance, it is position. Right, C. Calculate the total distance traveled. What is the total distance? Is it 10? No, huh? Okay. Now, when you see this 10, doesn't mean that the answer is straight away 10, because this is what? Position, right? So you look at the motion that I sketched. I go to the right 10 meter. I come back 10 meter. What is the total distance? 10 plus 10, 20. This is my answer. Okay. D. Calculate the average speed. Okay. Average speed is something that is always asked. Always. Okay. In your test, definitely it will come up. Okay. So average speed, how do you find it? Same thing. Average speed is just total distance divided by total time. Okay. Then you get 20 divided by 20, 1 meter per second. Okay, total distance are not displacement. That's why we use 20, not 10. And E. What is the total displacement in the 20 seconds? Displacement. I started at point O. I moved 10 meters to the right at point A. I took a rest and I come back 10 meters. What is my displacement? I come back to the original point. My displacement is 0. It's like I had not moved at all. So 0 meter. Okay, it's like you run a track, no matter how far you run, okay, 10 km, you come back to the same point in 1 hour. I asked you, what is your displacement in 1 hour? 0. Because you have traveled, but your position doesn't change after 1 hour. Okay, I don't care what you went through during the journey. What I care about is the initial and the final. You are still there, you started there, you are still there. So 0 meter. All right, so example 1, take note. You want to be careful with the graph sometimes, because they give you, you want to be careful with the unit. Okay, the unit. Sometimes they give hour over here. And if you forgot to convert the unit, then everything, the ABCD all wrong, especially in the test or the exam. Okay, one more question, then we will go to the VT. Okay, let me get some space here. So I erase this. Now, looking at the graph down here, try we sketch the motion. The first part of the graph, sloping down. What does it mean? Okay, let's pick one starting point. We pick a reference point first. This is my reference point. Let's call it O. Reference point. At time 0, where do I start? I am at positive 10 meter from my reference point. Okay, so I start here. Point A. What is this? 10 meter. Okay, so this is point A. And then you can see in the first 5 seconds, I move to 0. After 5 seconds, my position is at 0. So meaning that I move from A to O in the first 5 seconds. Okay, now, and then the next 5 seconds, where do I go? This one, the line continue to the negative. You see, at first your position decrease, right? Plus 10, plus 9, and then 0. You are now at the starting point. And then you continue to go -1, -2, -3. That means you continue to move. You continue to move to the left for another 5 seconds. Reach point B. How far away? 10 meters. Okay, this is point B. Right? And then what happened next? From 10 to 20 seconds, your position stays at -10. So you stay at B. You took a rest for how long? For 10 seconds. All right. And then again, from here, the last part of the graph, this one, what is this? You see the value, -10, -9, -8, -2, and up to 0. So it is getting less and less negative. That means you are going back to the right. Here, -10, -9, -2, back to here, 0. In 5 seconds also. Okay, so here is O. That shows your motion. Okay, you need to be able to describe the motion from the graph. Now, once we have understood the motion, now we go on solving the questions. A. What is the total distance? Okay, 10 plus 10 plus another 10. 10 plus 10 plus 10. 30 meters. B. Calculate the average speed. Okay. 30 over total time. Total time, do you need to add the 10-second rest? Yes, you need to add the 10-second rest because the 10 seconds is also a part of the journey. So the average speed, you need to add it, divided by 25. Okay, 10, 20, 25. Okay, so since it is speed, I do not need to worry about the sign. Okay, C. Calculate the speed in the first 5 seconds. Okay, that means we take the gradient of the sloping down line. Ten divided by 5. Do I need to put a negative? Since it is sloping down, right, the gradient. I do not need to put. Why? Because the question only one speed. That means this is only magnitude. So I will drop the negative. Okay, 1 minute and we go to the next one. Okay, next one. Now we will go to the VT graph. Now, everything you learn in the ST, apply for the VT in terms of the gradient. Okay, in terms of the gradient. So the gradient of ST is the velocity, and we have a gradient for the VT as well. What is it? What does it equal to? Let's see. Here is our pole. Let's say a car started here. Okay, we take the same example. And when the car started at the pole, we press the time 0. Now, the initial speed doesn't necessarily need to be 0. Okay, it could be that the car is initially moving towards it at a certain velocity, v. And when it crosses, I time it, I start timing, then whatever is the velocity, it becomes that initial velocity. Okay, but let's just say that we start from rest. Okay, so T0, V is 0 after 5 seconds and 10 seconds. Interval of 5 seconds, our speed goes on 10 and 20. Okay, then we sketch the graph. 0, 5, 10. 0, 10, 20. It's the same shape, a straight line graph, like the displacement time. Okay, now the gradient of the graph, VT, So this one, look at the unit V meter/second. T is in second. If I get the gradient, which is change in the y divided by the change in the x, m equals to change in y over change in x. That means it's the change in the velocity over change in the time. I put the unit in ms minus 1 divided by s. What do I get? This one. S minus 1, I can bring it down. M over s dot s equals to m over s squared equals to ms minus 2. What is this? This is the unit for acceleration. So from the unit, I know that gradient of a vt is going to be acceleration. This gradient, is it same or changing? A straight line, right? So constant gradient. That means this is constant acceleration. Okay? Constant acceleration graph. You get this one. So what does the velocity time graph tell you? Let me write it here. The VT graph tells you the velocity at a particular time. And the gradient of the graph tells us acceleration. Okay? The graph itself tells us the velocity at a certain time. It doesn't tell us the change. Mind the word, I say it again. The graph tells us the velocity at a particular point in time. It doesn't tell us the change. What tells us the change? The gradient is the one that tells us the change in the velocity. So the gradient is the acceleration. Okay, change in velocity. So acceleration is change in velocity. Now, the difference between the same shape but different graph, ST and VT. Okay, we do the same shape on the x-axis. It's VT. What does it mean? This one is at rest. Okay, because it's zero velocity. Now, what about if I move it up here? Okay, so here, positive 5. Over time, velocity stays the same, plus 5. So it is moving at constant v. If this was st, what would that mean? If this was st, like the st horizontal, this is at rest, right? If you revise back the one that we covered just now, right? So over time, what does the S show you? The position. So over time, your position is the same. You are at rest. But this one is V. So over time, your V is the same. You are moving, but you are moving at constant velocity. If I want to convert this graph to the ST graph, how would it look like? This graph, constant velocity, in the ST graph, it looked like a straight line. Okay? 因为你看 ST graph 的 gradient 是 velocity 对吗？如果你看这个 ST graph， 它的 gradient increasing 还是 decreasing 还是 constant？ 这个的 gradient 是 constant， 意思是说我们的 velocity 是 constant， 所以在你的 VT graph 里面，你的 line 就是 constant at 5。Okay, so let me box this. This one is the same as this one. Later, after we have done all the motion graph, I will teach you how to convert the graph from one to another one. Okay, all types of graph from V to S and to acceleration time graph, because sometimes in the SPM, they will ask you to convert between graph. This graph look like this. What is the graph in acceleration time? You need to be able to convert. Okay, that one later. Right. So what else? We have another type of graph. The curving one. Okay, let me get some space. I clear this one. If you want to take down, you can take down now. I want to clear the graph in the middle.我们还有 delay 多2个星期没有这样快做 physical。看到 after 2个星期过后的 case 怎样 ？But I don't think we will resume anytime soon. I think it will be delayed further. But I'm aware that some of you are not prefer to do it online. I mean, it's fine. It's up to you. Okay, so we continue. One more graph here. So same, 0 second, 5 second, 10 second, 50 second. And it shows the change in the velocity, 0, 10, 30, 60. If I plot the graph, you will get a curve graph. Okay, you can already guess it. 0, 5, 10, 50. Here and here. Okay. For the same amount of time, 5 seconds, what is the change in the velocity from here to here? 20 meters per second. The next 5 seconds, same duration, the change in velocity is 30 meters per second. Acceleration equals change in velocity over time. When the time is the same, this one goes on increasing, acceleration increasing. Okay, so this is, what graph is this? This is a graph of non-uniform acceleration. Why do I call it non-uniform? Because your acceleration is changing. Non-uniform acceleration. Okay, your acceleration is changing. Normally we do constant acceleration. Okay, we do uniform acceleration. This graph, every second the acceleration changes. it gets steeper and steeper. If you look at the gradient from left to right, gradient increases. Okay, if you still not sure how to read the gradient, you have to practice that one. That one is very important. You need to be able to read the gradient without calculation. 2 points A, B. Where is the steeper one? B is the steeper one. Okay, you can think of this like a mountain lah. Okay, it's kind of like a hill. Okay, you go uphill, this one is getting steeper and steeper. Okay, so this graph actually increase in gradient. And if I have another graph like this, imagine this is a hill. At first, it's very steep. Okay, at first it's very steep, and then when you go to the top, right, it starts to flatten. So this one, that means the gradient is decreasing. The steepness, okay, the slope of the hill is decreasing. This one, the gradient is increasing. If you know how to read, okay, that's good. But if you're not sure, you need to know that. Okay, because without this one, you will find it very struggle when you do the motion graph, especially when we come to the conversion of graph later. Okay, so once I can see the gradient, then I can see the acceleration. This one, acceleration increasing. This one, acceleration decreasing. Okay, 然后 question 如果他讲 find the instantaneous acceleration. Instantaneous acceleration at t equals to, okay, 12 seconds. All right, then we find 12 seconds. Draw a tangent. We calculate the gradient of the tangent. We get the instantaneous acceleration. Later, we will have a lot of exercises. Okay. One more thing is the VT graph. You got one more thing is the area under the graph. The area under the graph is equal to what? Distance travel, okay, displacement. The area under the graph is equals to the displacement. Why displacement? Because area of the shape is x-axis times y-axis, right? X-axis times y-axis. What is your displacement formula? Your displacement formula, V equals to S over T. S is V times T. S is V times T. So when you times the base of the triangle with the height of the triangle, you are also multiplying the T and the V. That's why you get displacement. That is why the area is displacement. Okay, now I will show you one example on the calculation of the VT graph. Okay, before that, 1 minute and I will go to the next slide. Okay. A, calculate distance traveled. What graph is this? VT. So to calculate distance, get the area. Area of D, or area of what? Area of the line, the space between the line and the x-axis. That means the entire solid. Okay, the entire solid. Can you try it first? You try it first, then we look at the answer. A, B, C, D. You can get the, you can cut it into sections. 如果我要找它的 area， 我分它成不同的 shape. Okay, let's say I cut here. I cut here, I get what? I get a trapezium, right? And I cut here as well. I get another, a rectangle. And then I get a triangle. So I'm just gonna name this A, B, C, D, E, F. And you want to calculate the area of each shape. What is the area of A? Okay, the area of trapezium. You can even, if you, let's say you forgot the area of trapezium, what do? You can cut it like that also. You cut it into smaller pieces. You get a rectangle and you get a triangle. Okay, but the area of a trapezium, what is it? Half times A plus B times the vertical height. What is the A and the B? The A and the B is the minor length and the major length. Okay, A plus B times the height is the vertical height. Okay, then we can put in here. That is for A. B. Okay, then you add up. So we have calculated all the area. Of course, this shape you can straight away calculate at once. Okay, this DEF is a trapezium as well. Okay, but still you get the same answer. Okay, we add up the area. We get what? How much? Total we get 140 meter. Total area 140 meter. So this is the distance traveled. Now 关于那个 area， 如果你的 shape 是在那个 x axis 的上面，它是 positive area。如果你的 shape 是在 x axis 的下面，它就是 negative area. Let me write it here. Area above x axis is a positive. Area below x axis is a negative. 这样证明什么意思呢？意思是说，这一边全部你拿到 positive area， 这一边你拿到的是 negative area。意思说，你算到的 area 在下面这边呢，它其实是走 ，it is moving backwards. Here, if I add up the area ABC, 30, 40, and 20, that means from 0 second to 15 second, 0 second to 15 second, the object is moving, okay, at a distance of, in one direction, this is all in one direction. This is in one direction, let's say to the right, okay, to the right. Then you add up the 30, 40, and 20, 90 meter. It is having a positive displacement of 90. And then what happened from 15 to 13 second, 15 to 30 second, the graph under it, it is a negative displacement, right? So negative displacement, what is this total of? 25 and 25 is a 50. This is minus 50. That means from 15 to 30 second, it is moving backward 50 meter. This is t equals to 30 second. Why is it moving backward like this? Because the area is negative. Okay, the area is a negative. It's a minus 50. So it is moving backward. You can see the velocity as well. If you look at the velocity axis, I mean the graph, starting from 15 second onward, all this is a negative value. That means velocity negative, it is moving backwards, starting from 15 second. Okay, you can see the graph goes to the negative region. But for A, since we are only finding the distance travel, it doesn't affect anything, 90 plus the 50, because it's distance travel. But when you look at B, the calculate the displacement, then it affects it, because what we are looking at is this one over here, 90 minus 50, this is 40. This is a plus 40, because my final position is over here, which is 40 meter to the right of the 0 second. Okay, to the right of where I started, my starting positions. So your B is a plus 40, meter. You see the difference? Distance and displacement. So what is exactly the area under the VT graph? The area under the VT graph is a displacement. Okay, it is a displacement because it can be positive, it can be negative. Sometimes they call it distance because distance and displacement, they use it interchangeably. The only difference is one has sign, one has no sign, right? If I only want to know the magnitude, then saying displacement and distance doesn't make any difference, since I only want to know the magnitude. Okay, AB done. CD. Calculate average speed, C. So average speed, you just take total distance, which is 140 divided by total time. 30秒. 4.67. D, average velocity. Okay, average velocity is total displacement divided by total time. So it's a plus 40 divided by 30. You get 1.33.